study about operational research. The operational research, what is operational research? It is a mathematical approach which we mainly need in business purposes. Like in business, there are two main keywords. First is profit and the second one is cost. In business, we need to maximize our profit and minimize our cost. We need to maximize our profit and minimize the cost. So we have to do some mathematical work, some mathematical approach, so that we can maximize our profit and minimize our cost. So from this relation you can say that profit and cost, these are inversely proportional, means as profit will increase, cost will decrease and vice versa. Okay, so the mathematical approach by which we solve these operational research problems is known as linear programming method. Linear programming or LPP. So there are many sort of linear programming problems where some things we need to keep in our mind. First is there is a objective function. Say this is the objective function. We denote the objective function with Z. Means we need to maximize or minimize these functions. Some supportive constraints. Constraints means there are some support, some equations which support this main function. Subject to constraints, say this is an arbitrary equation, okay. See, why it is called linear programming problems? Because all the equations are linear. What are linear equations? Linear equations are those equations in which the power or the exponents of the variables are 1. Like when we will plot in a graph, the result will be a straight line. If the equation was quadratic, then the graph will be like this or like this, whatever, means a parabola, ellipse, hyperbola, whatever, circular. So when we are doing a program on linear programming, we need to keep some things in our mind. First, we have to give two if-else statements. I know that you all know about if-else statements in programming language. So first condition is if the equation is not linear. If the equation is not linear, then a message will be printed that we cannot solve this linear programming problem as the exponents of the variables are not linear. If the exponents of the variables are linear, then it will go to the else portion and then it will go to the else portion and then the program will be solved. Okay. Second thing, we have to check that the value of x is greater than equal to 0 and value of y is greater than equals to 0. Another check, if then only the program will be executed. If x greater than equals to 0 and y greater than equals to 0, then only the program will be executed, else a message will be printed that we cannot solve this linear programming problem. So what are the two if-else statements? First if-else statement, that the exponents must be linear, means the power must be 1. Second, the value of x and y must be greater than or equals to 0. If the value of x is less than 0, y is less than 0, then we cannot solve this linear programming problem. Okay. So, first approach we can see is known as the graphical approach. Where we treat this equation as equal to, we remove or we neglect the less than or greater than sign. So these are the two constants. So first, okay, so what we will do, we have to convert this right hand side is equal to 1. So dividing the equation came like this. Second equation, so the two the two pairs of coordinates which we got, they are 1 by 3 comma 0 0 2 and this is 2 0 0 6. So draw a table like this. For A, when x is 1 by 3 for A, y is 0, when x is 0, y is 2. Draw similar table for B. When x is 2, y is 0, when x is 0, y is 6. Now, let's draw the graph. As you can see, the values of x and y both are positive, so we will take only the first quadrant. We will not take the second, third or fourth quadrant when either x or y or both x and y are negative. As all the values are positive, we will take only the positive quadrant or the first quadrant. So starting from 0, say it's 1, it's 2, it's 3, 4, 5 and 6. Just erasing this part. Okay. Okay. So, what is the first point? 1 by 3x, value of y is 0. 1 by 3 means it lies, 1 by 3 means it is 3 point something. Means it will lie between 3 and 4, somewhere here. And when x is 0, y is 2, here. So join this line. Now, when x is 2, y is 0. When x is 0, y is 6. Join this line. See, here an intersecting point came. It is somewhere in between 1 and 2. Say it's here also. Say we take 1.5 comma 1.5. 1.5. Okay, so we will take 3 coordinates, one this one, and one say suppose this one, and one say suppose this one. Okay, and the feasible region is here. Okay, so the 3 coordinates which we got, they are, say D 1.5 comma 1.5, A 0 2, B 2 0. Okay, now we will place these values of x and y in the objective function. For example, we are given to minimize the cost. The problem is to minimize the cost. Then whichever value of z will be the least, we will take that value of x and y as our result. Okay, so if we put z is equal to 6 into 1.5 plus 5 into 1.5, so it comes 9 plus 525, 7.5. So it comes 10, 11, 14, 15, 16, 16.5. When we put this value, now putting this value, z is equal to 6 into 0 plus 5 into 2, means it's coming 10. Now putting this value, see the three answers which we get, 16.5, 10 and 12. So which one is the minimum? 10. What points we have taken, which we have given to get this result? 0 and 2. 0 and 2. So answer, the value of x must be 0 and value of y must be 2, so that when we put these two values in the objective function, the cost will be reduced.